Hello, my name is Robert, an architectural designer, creator, and educator at Pratt Institute, and welcome to Designing Form Through Drawings and Model. In this video series, I'm going to introduce you to a step-by-step design exercise that you can do at home to start exploring architecture. Architecture is an art of form and material that creates our built environment and supports the activities of our lives. Together, we will explore a design workflow that translates 2D graphic compositions into 3D forms by cutting and folding. Design is often an abstract process through which you can discover tangible results and explore new potentials of form and space. This is a three-part video series, and each segment will focus on a different design technique that architects use to create form and space. In this series, I will cover three methods of designing that architects use every day: sketching, abstract drawing, and physical model making. The key design concepts we will cover include abstract graphic systems and figure field relationships, unfolding 3D forms into 2D assembly patterns, and folding 2D patterns into 3D forms. By following this tutorial and practicing the skills and concepts I will cover, you will be able to create many design artifacts and explore the relationships between 2D drawings and 3D form as a design process. You can continue to develop more refined studies and use calibrated photographic documentation to build an exciting portfolio of works. Step 1. Workspace setup, materials, and supplies. To begin, we will need to set up a few things. First, you'll need to find a stable work area. This could be on a dining room or kitchen table, a desk, coffee table, or even the floor. I'm going to work on my coffee table here at home. Go ahead and pause the video and find a space to work that is roughly 18 inches by 18 inches, so you have room to move around. Next, you'll need to cover your work area with something to protect it from accidental damage while you're working. You can use a cutting mat, as I have here, but if you don't have one available, a piece of cardboard from a box or a couple layers of newspaper will do the trick. We won't be doing too much messy work in this exercise, but it's good to be safe and organized. It also helps to have something under your work so you can pick it up and move it in case you need to relocate or take a pause. You can come back and start where you left off. Finally, you'll need to gather the supplies and the materials that we will be working with. Take a few moments to find these items. A rigid sheet material, something like a cereal box, cardboard, the back cover of an old notebook, some Bristol paper or other heavyweight paper, or any other paper-based sheet material that can be cut with scissors. You'll also need a pair of craft scissors, a pencil or pen, a 12-inch ruler, some tape, masking tape or scotch is fine, and a few pieces of blank printer paper or notebook paper to sketch on and use as templates. Some advanced materials you can use to achieve higher quality results include white glue like Elmer's or Sobo, as well as higher quality papers like museum board or heavyweight Bristol. These may also require you to use an X-Acto knife to cut the pages, as scissors tend to be difficult on heavier materials. We'll start with scissors because they're a little bit safer and everyone probably has a pair at home. This is intended to be something you do multiple times, one to improve your craft and your design skills, and also to start to generate a body of work that explores one theme. This is a very important aspect when developing a portfolio, as you show not only finished examples, but how you thought through the design process to develop something that speaks clearly about your intentions. Sometimes this is referred to as a concept. Step 2. Sketching exercises, the cube. Now that you are set up with a workspace, tools, and materials, let's start designing. We will begin with a sketching exercise to familiarize you with the object of your design. Sketching is a way of thinking with your hands, eyes, and mind that can quickly represent ideas and explore design possibilities. This is a cube. You are probably all familiar with it as a geometric form and a plutonic solid. I even suspect that all of you could sketch this on a piece of paper without any further instructions. Feel free to pause the video now and give it a try. Once you have the three visible faces of the cube, you can use light dashed lines, as shown above, to expose the three hidden sides. Go ahead and add them to your sketch. To help us track the cube's faces, let's label them 1 through 6. I'm going to label them in the corners that touch each other based on the front and the back sides of the cube. You could also label them top, bottom, front, back, left, right. That is a lot more to write onto your paper and only matters if we know the orientation. Now let's consider what we know about a cube. It has 6 sides, and each of those sides is a square with equal lengths to all of its edges. All 6 squares connect to one another at their edges at 90 degrees. A cube also forms an interior space that is closed from the exterior. This gives us a way to start to explore spatial conditions in architecture. The example you see here is a cube drawn in an isometric view, which is a type of axonometric drawing where all axes, the x, y, and z, are drawn with equal lengths. As you notice, this hides part of the cube, and we can only see 3 of the faces. There are many types of these abstract, what are called paraline drawings, that you can use as a way to represent objects in space. A few of them are displayed above. We have things such as plan oblique, elevation oblique, and other angles of rotation to the 3D object. If you want to explore more about this, I suggest to find a copy of Francis Ching's Design Drawing as a great introductory book to all different types of drawing for representing your ideas. If you haven't already drawn a cube similar to the one in the video, take a few moments to sketch it on some paper. Now we can think about the cube as an empty box and sketch it as an unfolded 2D pattern made up of 6 equal squares. Here's an example of the unfolding box that generates a 2D pattern. We will also refer to this as a graphic figure for our design studies later on. Take a few moments and see how many different ways you can sketch an unfolded cube. Remember to label the faces. How many did you come up with? Here are a few more for inspiration. Which ones do you find to be interesting shapes? Each organization of 6 squares describes a pattern for folding a 2D shape into a 3D form. They are also graphic figures which you can use to design conditions in architecture. We will revisit this and these figures as a design tool later in the video series, so keep these sketches handy. Now is a good time to take photographs of what you have done. As you can see in the video, I'm using my phone to take a flat picture, kind of like a scanner would do, but it's a quicker way to get this recorded for you to use later. Now that you are familiar with the cube as a 3D form and a 2D figure, let's draw the unfolded pattern onto your cardboard sheet material for making your model. For this video series, we will be making a 2" by 2" by 2" cube. You can make a larger cube by adjusting your measurements and using a larger piece of material. It is sometimes easier to work on a slightly larger cube, but if you go too big, the material might become floppy and no longer hold the shape. If you're using a very light material, it is easier to work smaller so that you can hold the edges together. For this step, you will need a few things. You'll need to select your cardboard or other paper sheet material that is at least 8.5 by 11 inches, similar to a normal piece of notebook paper. Depending on the unfolding pattern you chose, you may need a larger sheet. You will also need a sharpened pencil or a pen to draw with, as well as a 12-inch or longer ruler. We will begin by defining the boundary of the unfolded cube pattern. If your material has uneven edges, don't worry, we can establish a baseline and work independent of the material's edges. First, you will locate an origin for your drawing in the lower left corner of the cardboard. This should be about 1/4 to 1/2 inch away from both edges. It doesn't really matter where you place it, it's just to give us a clean starting point. Next, use the ruler and your pencil to extend a horizontal line along the long edge of material the full length of the ruler. These next steps are probably the most difficult since it is easy to introduce inaccuracy when measuring. Take your time and try to keep everything straight, perpendicular, and parallel. If things get a little off or you make a mistake in measuring, it is okay. You can always erase the line and try again. Try to draw the lines lightly so they are easy to adjust, and then you can add darkness to them later to make parts of the drawing more clear. And remember, don't panic and take your time. From the origin point that you drew first, we will need to also draw a vertical line perpendicular to our first line. You can carefully use the rectangular shape of the ruler to approximate a 90-degree edge and draw the line. If you have access to a square or drafting triangle, that is a more accurate method, but the ruler should work well enough in this case. If you're using a piece of paper with straight edges, something that came pre-cut, then you can rely on those edges as your measuring marks as well. Our next step is to divide the horizontal line into 4 equal 2-inch segments. Place your ruler along that line and use a pencil to add light tick marks to the edge. Note that some of the folding patterns may be different in width and height, and you can adjust based on what you've chosen to draw, or just follow along in the video. The video is based on the most basic unfolding pattern that we're all probably familiar with, and this is a good place to start. Go ahead and divide the vertical line in the same way that we did the horizontal line, giving it 3 equal segments of 2 inches each. This should start to look familiar to you, as we are basically creating a graph with an X and Y axis. Another way to do this is to use a guide that is a square, such as a piece of 8.5 by 11 printer paper. With the sheet of paper in landscape format, start measuring from the lower left corner. Divide the bottom and left edges into 2-inch segments with a tick mark on the edge. Then divide the top edge starting from the left so that the ticks match the bottom. Repeat this for the right edge from the bottom to the top, again so they match the left edge. Now you can use this sheet of paper as a guide to transfer the measurements to your cardboard. This is especially helpful if the sheet material you're using comes from an uneven source, say a cardboard box. With our origin and XY axis defined, we can create a 2-inch by 2-inch grid that allows us to develop our folding pattern as a 2-dimensional shape. Start by measuring 6 inches up from each of the tick marks on the horizontal line. Do your best to keep the ruler parallel to the vertical line. Next, use the 4 points across the top to draw a second horizontal line connecting them all. Now do the same for the vertical line, translating its points 8 inches to the right, parallel to the top and bottom edges. If all of this sounds pretty abstract, follow along my steps in the video. You should have a drawing that looks like this. It is an 8-inch by 6-inch rectangle. Use the ruler to divide the top and right lines into equal 2-inch segments similar to the bottom and left. This will verify your earlier measurements and make sure that you're going to draw parallel and perpendicular lines across the interior space of the rectangle. Now connect all of the horizontal tick marks to form a series of parallel lines. Do the same for the vertical tick marks. You now have a 2-inch by 2-inch grid that is 4 units wide and 3 units high. If you are exploring a different folding pattern, you may need a different grid. Architects often use an underlying grid for planning things such as structure, spatial layouts, or just helping with drawing orthogonal relationships. The final step for this section is to use your pencil and ruler to highlight the squares that connect to form the folding pattern. Using your ruler to do this will provide a much crisper edge and make your drawing look much more professional. Once you define the boundary of each square, you can use a pen or a colored pencil to highlight the outer figure of the pattern's shape. Now we have a base to start designing with figure-field relationships. This is something we'll cover more in the next segment as we talk about abstract pattern. Before moving on to the next step, you should take a photograph to document your progress through this design process. Use your phone to match the flat photograph in the video. This simply means to hold your phone directly above the piece of paper and make sure it looks square on all edges. You don't want any tilt here because you're going to use this in our second video series as a starting point, and the flatter you can take your image, the better it will reproduce in formats such as Portfolio or in a translation to digital modeling. I always like to take a few just to make sure I have good focus and crisp edges. Step 4. Designing graphic figure field compositions. Architects often design in 2D drawings and then translate these designs into 3D forms. One way to do this is by using a grid or a field condition to explore the relationships between graphic figures. Here are several examples of ways to define your own grid as a system of horizontal and vertical lines that develop out of parallel sequences to start to describe rhythms across the space of a page. I will demonstrate a simple uniform field based on subdividing the square faces of my cube with a 9-square system. The 9-square organization has been used for hundreds of years by architects as a design device. If you want to check out more about this, you can look up Andreas Palladio, Peter Eisman, or John Haydock, as they've all used this in their work, some of them very contemporary and others from the early Renaissance. If I look at one square in my unfolded pattern and I want to divide that square into 9 equal squares, I can use my ruler and pencil to subdivide each edge equally into 3 segments. I would draw a tick mark approximately every 0.67 inches, which is pretty close to 5/8, but it depends on how accurate your ruler can be. The one I have here can measure down into the 16ths, and it would be better to be closer to 11/16. That is a lot of finicky measuring and a lot of chance for error. Having equal segments is not really important, and I think if you go and examine some of the work of Palladio and the further analysis, you'll see that architects often work with rhythms that are not always consistent. If you are working without a very precise ruler, and this fine degree of measurement may be quite difficult, it is okay to choose to have unequal segments. This is a design decision, and it will have interesting effects on the outcome of your final cube. Feel free to explore several rhythms by sketching them out on a blank piece of paper and thinking about how they divide the space of a square. I think that 5/8 is not too hard for me to measure, so I'm going to use that. To make sure that I have consistency, I'm always going to do my measurements in the same way. I will start from the corners of each square and measure in 5/8 from each edge. You can see me doing it in the video here. Once I have marked off all my tick marks on the edges of each square, or as you can see in the video, I've decided to move out from the squares towards the edge of my larger rectangle. This is just a technique that allows me not to have to place tick marks in my drawing so they don't disrupt the clean lines that I'm going to draw later. Once you have divided all the edges of each square, go ahead and use the points to divide the whole rectangle into a field of horizontal and vertical lines. You are basically creating a grid, but with new sets of rhythms that you are designing. As you can see here, I've increased the speed of the video to get through the process a little bit faster, but measuring all of these tick marks accurately and making sure to connect them with horizontal and vertical lines takes a lot of practice and a lot of time. Work slowly and make sure you maintain accuracy so your final result will be a clean, clear grid space and doesn't have a whole lot of wiggles or distortions. Welcome back. Now that we have a field to work with, let's select a graphic figure to design with. Remember that sketch of all the possible ways to unfold the cube that you made earlier? We're going to bring it back and take a look at it to define our graphic figures. Go ahead and select a shape that you like. Maybe you like the way it bends or aligns or wiggles. Maybe you can just name it as a letter or a shape that you recognize. Maybe you like it because it looks like something from the game of Tetris. If you can name the figure based on its shape, that is a good way to make your decision. I'm going to work with this flipped L-shaped figure. As you can see, it has two kind of even L's flipped and then put back to back. It also makes kind of a nice condition with two different sides, one stepped large and one stepped small. This is kind of like a game of Tetris or any other 8-bit video game from the 1980s. We are playing with pixels to define a larger figure that we can manipulate as a design tool. With your figure selected, you can start to find it within the field. First, I might just select an intersection, the space between two faces of the cube, or the edge, where the squares meet. And I can use my pencil to lightly outline and shade the 6 grid squares to form the flipped L-shaped figure. I'll find a few more conditions in this field that are similar and add more shapes. Keep in mind that shapes can rotate, flip, move, and scale to design different organizations. As you can see here, I'm starting at the edges between squares and thinking about the orientation that might work best. At first, this may be kind of a random process, but as you start to play with it, you can consider how this is related to the corners, or to the edges, or to the adjacent faces. Try to come up with a reason for why you're placing these shapes, as that will help to guide the design and fill the field with multiple interacting figures. I'm taking my time to shade carefully so that I can fill in evenly between the lines, and this will take a nice picture that I can use in my portfolio. After you fill in 5 or 6 figures, you can start to see a graphic relationship developing between the shaded positive space and the empty negative space of the field. Colored pencil or marker also work, and as you can see here, I'm beginning to outline mine using the ruler and a pen to make the initial figures stand out more relative to the field that is developing between them. Some ways to make it more interesting are to consider how shapes touch each other, how you move between shapes by changing its size or position and rotation. One thing I like to do is change their scale by giving it rules, such as 1 pixel in the original shape now takes 4 pixels in the shape I'm going to draw. Or maybe changing it by stretching it by having 1 pixel only require 2 pixels in one direction and still one in the other. Now you can use your shape to try to connect multiple figures together. Take a few minutes to find shapes that connect your initial figures into a design. This is something you can play with as you explore these designs. If you have some graph paper around, you can play the game very quickly there and test out how you might want to use your figures to form a larger pattern before you come and do it on your final piece. I'm going to go ahead and use a consistent scale of figure here and just try to fill in a good density where I have some positive space and some negative space evenly distributed over the faces of my cube. As you notice, several of my figures go outside the space that I defined for folding the cube. This is okay, and we'll look at later how we might use this in our design. Try to fill up the whole page if you can, and don't worry that some parts of the cube are not covered. I'm taking my time to shade carefully so that I can fill in evenly between the lines, and this will take a nice picture that I can use in my portfolio. That's it. If you have something that resembles my drawing here, you are designing. To enhance your 2D graphic figure field design, you can carefully shade all the positive figure space darker with your pencil. As we've done already, before moving on to the next step, you should take a photograph to document your progress through this design process. This is important for building out how you think in a portfolio. Use your phone to match the flat photograph in the video, making sure that the figure doesn't appear warped or distorted. You may need to use some tape to hold it down if your paper or material is starting to warp. Step 5. 2D to 3D, cutting and folding the cube. Now that you've created a 2D folding pattern with a graphic figure field design on it, we are ready to make the translation to 3D form. If you haven't taken pictures to document your work, please take a few moments now to do so. You're going to cut your figure field drawing and use it as instructions to design a cube that opens up and provides access to the interior spaces. This is a destructive step, so it is very important that you document your work. Here is the graphic composition that I created in the previous video. I experimented with a couple of versions using the same figure with slightly different rules for inhabiting the field. The one on the right was done very quickly, and you can see that the quality is quite different. It is important to do quick sketches and tests, and then to redo them with precision for your final production and documentation in your portfolio. Let's look at some of the aspects of the two designs. Both designs have a diagonal stepping quality along this left edge, your left. There's a similar density of clustering of shapes, making a larger figure here in the right corner nearest to you. And they both have a strong longitudinal spine down the main axis of my folding pattern. There's a few other differences where a few shapes stick out on one or the other, and this is normal as design is a fluid process. You can see that there are many figures that extend outside the boundary of my unfolded cube pattern. This is okay, and as we've explored before, this is part of your design. Designing form is a very flexible process, and there are many opportunities at each stage to make decisions and explore how they affect the outcomes. We will use these as part of our design in just a few minutes. So let's get cutting. I'm going to primarily use scissors for this since you probably have a pair at home, but I'm also going to show you how to use a craft knife like a box cutter or an X-Acto, which can be very helpful for some of the complex cuts. I'm going to work on my test design to get the hang of cutting and making. Then I can go back and make a better model with my nicer drawing once I have the skills under control. You'll have to take your time with scissors to make straight and clean cuts. If you have a craft knife like this box cutter and a metal-edged ruler with a non-slip back and a cutting surface like this cutting pad, you can use that to be more precise. But remember, these knives are very sharp and they can cut you or the surface underneath your drawing very easily, so only use them with proper equipment, patience, and care. I'm going to go back to using the scissors, but I'll make note of places where the knife might be most useful. I'm going to start with the easy cuts. Long straight cuts work well with scissors, but these short cross cuts that are in between shapes will be kind of challenging. It's good to organize your workflow, and I like to make all the easy cuts first to get the material out of the way to make it easier to work on the hard cuts. See how I am incrementally removing the material from the outer edge? I am also cutting to the outer edge of all of my figures so I can experiment with them as part of my cube space later. That's pretty good. Now time to deal with those challenging interior cuts and empty areas that fall outside of my original folding pattern. You can see that I'm working through these cuts in small steps, making as many easy cuts as I can before using this folding technique to cut the tabs. I carefully fold the paper on the line and then use the scissors to cut it from the back. This is where a knife is very helpful, but you have to be very careful for yourself and your table. When you fold the tab back, use the grid to align it to make sure it's perpendicular and parallel to all the other edges of the field. This way you'll know you'll have a nice straight cut. Once you finish trimming the figure, now take a few moments to clean up your work area. You can save the scraps for later and to make another model, or discard them in the trash. This is a good time to document your progress to show the transformation of the drawing from a 2D graphic into a 3D material artifact. Step 6. Space, assembling the cube. You have made it to the final step of the process. Working from sketches to unfold a 3D form, a cube, you have designed a folding pattern, an organizing field, a graphic figure field composition, and a test configuration of your 3D folded cube. To complete your object and your design of form and space, we will now cover assembling the cube. Let's examine the cutout figure field pattern, which has now become much more of a material figure since we removed the context of the field. It looks like I may have missed a couple of blank areas. I'll go ahead and snip those off quick. Please review your figure as well to make sure you caught everything. Now I will examine the relationship between my original folding pattern, the 6 squares of the cube, and my figure to come up with a strategy for refolding this back into a cube. It can help to start by lightly folding some of the edges to visualize how it will work. This edge is in a good place to start because it is not deviating from the original pattern, and therefore I can fold it pretty easily. To continue folding the cube, I will have to decide how to cut the shapes that leave the boundary. This is another design decision, and it can have interesting effects on your final model. There are no right answers, and I will explore a few strategies here. First, I will decide which face of the cube the shape should stay with. To keep it simple, I will try to keep the extra shapes with their original figure. You could also have them combine with new figures or wrap around edges that you think they fit with best visually. I switched to using my knife here because it is faster for the video, but you can stay with your scissors as they work just as well. You might decide to remove some more of the blank areas as you get into the folds. This is another design decision, and you should try to be consistent with how you make it. I am removing all blank areas that are outside of the folding pattern in my case. I am working my way around the edges to make a similar decision for each edge-to-edge connection. Once I free up a square from the folding pattern, I give it a light fold so I know that I am done, and so I can start to see the cube forming as a 3D object. Now that my edges are free, I will fold the edge of the original 6 squares to transform my flat pattern into a 3D form. Be careful to fold your edges straight and crisp. You can use the underlying grid to make sure everything is staying parallel and perpendicular when you align them on the back side of the paper. There we go. I have refolded my unfolded pattern into a cube with a few extra tabs. We will use these in the next phase to assemble the cube, as they are a good place to add glue or tape. Take a few moments to photograph the folding process and document the steps in the design. Since this is a dynamic process, it might be nice to document the steps of folding as you go through them, or to play with the piece and see how much it can fold up and out from a flat to a 3D object, and take photographs along the way. As you can see here, I am taking pictures from a 90-degree angle to the corner of the cube. This is very similar to the view of the isometric drawing we discussed in the sketching step. This is a good general view for documenting 3D objects like a cube, but doesn't capture all the nuances of the space that's starting to form inside. You can also experiment with capturing a time lapse of the folding process or testing different angles of folding and relationships to the table or surface that you're working on. This is another way of making space with folded forms. The final step in the process is to assemble the cube. I will use masking tape here. Scotch tape can work as well, and since it's clear, you'll see the drawings on the surface through it. With the masking tape, I will have to go back with a pencil and shade the areas of the tape over the shadings in my drawing. After you've made a few practice cubes, you can go ahead and switch over to using craft glue like Elmer's to make a much cleaner, stronger, and more precise model for your portfolio. I am also going to cut and use the blank spaces as either holes to see into the interior of my cube or surfaces that can fold and connect across other faces to help with the assembly. I will begin the assembly process by test fitting the edges of the cube together and deciding how I can use the shapes to extend beyond the cube. I will have to make a few more cuts so I can fold the extended shapes to work with the adjacent edges. You can see here that I decided to fold the shape that I cut to free it from the edge into the space of the cube. One reason for doing this is to get it out of the way of the exterior edges so they can fold and connect to each other, and the other is so that it subdivides the interior space into two new spaces that I can start to see as the scale of architecture. My folding paper cube is starting to suggest possible architectural conditions as the space within and between surfaces. Keep exploring how you can use the positive, shaded, and negative blank elements of your figure to fold in and out of the cube to provide an access to the interior as voids. What we have talked about as a figure field composition may also be referred to as figure ground or positive and negative space in terms of drawing. When we move into 3D, this positive and negative is the relationship between solid and void. Try to have a consistent way of working with elements. So the design has a conceptual rigor and clarity. You can always break your rules when you see an interesting spatial opportunity or material connection, but try not to do it every time you make a choice. Notice how I make a design move, test it, then make adjustments. I am not fixing anything yet, but I am making sure it will all work when I fold the cube back together. You'll find that you may have more surfaces than you want or need. It is okay to remove some. You can save them, and maybe they will be useful later. I'm going to take this edge off here because it's kind of cumbersome to work with. I'm going to hold it off to the side, and I'll come back at the end and find a new position for it to occupy to help enclose the cube space. I'm about ready to start fixing the cube together as a form using tape. I have a lot of these little tabs that will be helpful in connecting overlapping faces. I'm using my knife or scissors to cut small, even strips of tape that I can roll up and stick between the surfaces. These small strips can also connect around corners and between faces to help hold the cube together. Try working one side of the cube to the next and give the form some rigidity. As you connect more faces, the overall design will make suggestions to you based on the developing interior space and the remaining material. You can still remove stuff if it is in your way, or cut and reposition it for stability. As I have noted many times, design is a process. It works back and forth with the mediums that you are using to visualize space. There is rarely ever a right answer until you have spent time playing with your design and understanding how it works and how it can suggest space and form to you. If you feel stuck or lost, take a step back and rewatch the video and then try again. Often, my role as a teacher is to remind students to try again. I am almost done assembling my cube. The last few connections might be challenging since the space is getting tight and my fingers don't quite fit. If you have some tweezers, they can be helpful to place tricky pieces of tape and hold together two faces while glue or tape connects. My final step is to reattach a piece that I removed earlier. This looks like it might be a good roof condition, so I'm going to use it to wrap this side of the cube that's more open. Since the cube is abstract, it does not have a predefined top or bottom, left or right. Now you can use your hands and eyes along with sketching and photography to explore all the spatial potentials of your design. Imagine yourself as very small and occupying the space of the cube, like a tiny dollhouse. This is the way we think about things to scale when we're designing architecture with our hands. Take a look around and think about things like where would there be a good entrance, or a place to sit, a window or a skylight, maybe a secret chamber or a private alcove. Capture these moments with photographs using your phone, since it has a good camera for taking pictures of small spaces, and then print them and draw people into them, or use Photoshop. Congratulations, you've made your first model. Now, take a few minutes to explore it with photography. Here are some example photographs I took of my model here to show you some things to look for as far as documenting the spaces of the interior as well as the overall construction of the cube. There'll be a second module that looks at doing some of these aspects in a more digital way and exploring design ideas even faster through the use of computers.